We are looking at the Kelly criteria. For every dollar invested into two hypothetical stocks, the first stock is a star. It, on average, returns $2.70 for every dollar we invest. On the second stock, it only returns 30 cents for each dollar invested, a crashing performer. However, if we combine them into a two-asset portfolio, orthodox financial wisdom tells us that the expected value is invest 50% in each, 0.5 times 2.7 plus 0.3 equals $1.50, return of 12% return on investment, or $50 absolute gain. Looks good. However, under simulation of real-life trading, if we combine it to find the likely outcome, hence the product rule of combining probabilities by outcome of number 6 scenarios, gives us 2.7 times 0.3 to the power of 50. The real-life outcome, with trials where we have 2.7 times 0.3 to the power of 50, we get 0. The log optimal growth rate is merely the log of the two returns added together. Log 1 plus 2.7, log 1 plus 0.3, this is a log optimal growth rate of 1.3. We get a likely outcome of 0.8 times 1 to the power of 50. In other words, after 50 days, we are broke, or 50 trials. Here we have the scenario before, 2.7 plus 0.3 times 0.5, this is a 1.5 expected return. In real-life outcomes, a crushing expected loss. Now, to start off with a log optimal growth rate to find the Kelly criteria, I derived it analytically. I didn't derive it with calculus, I used numerical computation analytically with simple Gaussian, which is quite accurate. It's a significant rounding error. I'll show you the R chart so we can look at the actual derivation. Here, I'm running through a random sequence 100 times, and you can see the chart generating there. On the left downside, to a certain point, you wouldn't be making enough money to make it worthwhile. You're only making fractions of the same. But that shows that the optimal criterion is the log optimal point. Now we'll move on to the second spreadsheet where we're running Monte Carlo simulator. Anyway, the actual optimal return determined by our statistical language script is 42. There is a rounding of precision of a particular error with Excel Plus, but 81 of a cent, off roughly to the third decimal place. I subscribed to Frontline Solver when this was done, no longer. I would redo this another way today. Here is Frontline simulation for that, and we run it, and that is what the results are after 50 days. That one started at a profit of $150, an expected value, with 3 invested. And the log optimal growth started at an expected value of $1.57 with $3 invested. An expected value? Now we're running. I just press F9. You can see that the calculation run on the right is always superior, even when there's losses. It's 0.82 there, 0.59 there, 327 there, 45 to 330, 46. When it's down, that's lost almost just over half, under half. The Kelly criterion only lost about a half less or so. Whereas expected value nearly lost everything here, 39 cents, Kelly criteria is still 55.52. In every case, as in this example, there is a variety always new that time, and I have shown a representative sample. Okay, we'll move on. Thank you. The next few slides are from Wikipedia. They're generally well-researched, well-resourced, and clearly explained. The cost is a full Kelly. You can go broke in rare circumstances with it. You can go broke in extreme situations. Half Kelly would be very unlikely that you would ever lose all your money. As you can see, Kelly criteria is superior measure to the expected value of traditional finance. You're better off relying on Wikipedia than a lot of those infomercial blog sites on the internet like Investopedia. They're not reliable and they're highly inaccurate. You know, we'll flip through these next few, and you can just go to Wikipedia to read them if you need to. Thanks. Thank you. Share trading is difficult to do, far from what the so-called experts would have you believe. The Kelly criterion is a great weapon in your arsenal of share trading tools. However, like the computer rule of GIGO, which says garbage in and garbage out. Kelly criterion parameters can be difficult to arrive at empirically for all scenarios. And even if you can, even if they can be derived empirically, deriving the Kelly allocations is as much an art as a science. Your mean or return estimates have to be rock solid, or your whole assumptions are false, and the outcome from the formula is garbage in and garbage out. It is a deep topic which should not be left to the countless incorrect formulas purporting to the Kelly criterion over infomercial blogs on the internet like Investopedia, which is not a good source.